Hi everyone, welcome back. Let's look at more on simultaneous equations. Still going to stick to the same method as before and the things I prefer, but this time we've got letters missing. If I want to mark students up in an assessment, I'll leave out some of the letters. So for example, this hasn't got a Z, this one hasn't got an X, and this one hasn't got a Y. I've seen students over the years spend a fair bit of thinking about it, trying to think of shortcuts and ways through. I still like to think as much as possible stick to one method. You can just go, there's my method. That's how I do it. So here we go. If I write that as an augmented matrix, what am I going to have? That will be a 2. The coefficient of the X is a 2. The coefficient of the Y is a 1. There it is there. There's no Z, so the coefficient of the Z is 0. And then the constant, the number by itself, is the 5. There's no coefficient for X, so we put 0 for that. But there is a 2 for the Y. There's a 1 for the Z, the coefficient of Z, and there's an 8 again for the constant. This one here, there's a 3 as the coefficient of X. There's no coefficient for Y, so in other words, it basically means there's no Y, there's 0 Y, and there's 4Z, and that's 11. Now, I like to go to lowest common multiple all the time, lowest common multiple. There's something that's helped people over the years who struggle with this, being able to just suddenly go, yeah, I can do that without thinking. So let's ignore the 0, because if we multiply by 0, we get 0. So I've got 2 3s is a 6. So that one's a 6. The 1 times a 2 is the 2. The 1 times a 4 is a 4. Then you say, which one's the smallest? Smallest of it is 2. You could do it with a 6, you can do it with 4. Doesn't make any difference where you do it, but it's going to work out nicer numbers and smaller numbers if you stick to the one that's got the 2 on it. So what we want to do here is we want to turn both of these numbers here into a 2. And that's quite easy to do. If I go, here's my matrix again, augmented matrix. I want to write that as a 2. I've already got that as a 2. So I can go across and fill in the numbers if I wanted to. I've got that. So if I double that one, I have to double that one. I have to double that one, which is still 0. I double the 5, which is 10. So what I've got here now is what we call 2 times the previous row 1. So there's row 1. We've got 2 times that row 1. And down the bottom, nothing changed, so I've got 0, 3, 0, 4, and 11. Now if I take my matrix across to here, now there's my 2's the same, both the 2's are the same. If I want to eliminate one of those, if I want to get rid of one of those, if I subtract them, it'll eliminate it. So I'm going to go that row, subtract that row, which is row 1, take row 2. I'm going to leave this as row 1, so I'm going to write it down here. So in the middle, I've got row 1, take row 2. Let's do the calculations. 4 take 0 is 4. 2 take 2 is the 0. 0 take 1 is the minus 1. And 10 take 8 is 2. Now I've still got my first row there, nothing's affected that. I do prefer to write it back to the way it was, because these have become bigger numbers. I'd like to stick as much as possible to smaller numbers. By the way, over the years, the smaller the numbers, the less students make mistakes. Often I teach a topic with smallest numbers possible, so students aren't thinking about their times tables and their calculations. So I'm going to go back and write the 2105. I could say what I've done there, but don't need to. I've just written it back as that. Now the bottom line is still 3, 0, 4, and 11. Now let's have a look at what's left. We're talking about the variables, so these are both 0. So now I'm going to look at this pair here. I'm going to look at that pair there. Now what is their lowest common multiple? Now same as we did up here. Now that's a 12, whereas this one's got a lowest common multiple of minus 4. Smaller number just means the calculations will work out smaller. So if I multiply this row here by 4, so what's what I'm going to write? It's a 4 times row 2. That row 2 we're going to multiply by 4. I get a 16, that stays 0. This is a minus 4, that becomes an 8. This is still 2, 1, 0, 5, nothing changed there, nothing changed here. 3, 0, 4, and 11. And the interesting thing is they've got the same size. Not the same sign, but the same size, or we talk about same magnitude. If I come over this one over here, I have a rule which I call SSS. They're the same. If they've got the same sign, this is a positive and that's a positive, What am I going to do? I'm going to subtract. Same sign, I subtract. Let's come over to this one. They're the same size, but they're not the same sign. So I'm not going to subtract, I'm going to add. So if you don't understand really what's going on, you can get back to SSS. Let's write the first row down. I'm going to write this row back. Oh, by the way, again here, I don't want all these big numbers. I'll go back to the numbers I had. So that's a 4, a 0, a -1 and a 2. And I go down to what's going to happen down here. If I add the previous row 2 plus the previous row 3, so this row 2 plus that row 3, they will then eliminate each other. -4 plus 4 becomes 0. Let's go back over here. 16 and 3 is 19. 0 and 0 is 0. 8 and 11 is 19. And it's nice when you're making hoping you didn't make silly mistakes, they both say 19. They don't have to say 19. You can get fractional answers, decimal answers, and all sorts of horrible things. But to start with, on our cases, we're going to look at nice, easy cases. So the moment that says 19 and 19 with zeros there, we've eliminated the y's, we've eliminated the x. This is talking the z's. This is talking about the x's. So we now know that 19 x's equals 19, which is nice and easy because you can come around and go, well, that's x equals 1. And now I know that x equals 1, I can figure out what the others are. So I can go back through any of these equations and work it out. But if you look at this one here, this has got the x value, this has got the x value and the z value. This one's got the x value and the y value. So if I wanted to, I could go figure out the y value next. I'm going to go to the z though. So I've got a 4x minus a z equals 2. But I know that x is 1, so I've got a 4 times 1. Now a lot of you watching it now would probably go, I'm alright, I don't need to see the rest. You don't need to watch it through. So this is 4 take z equals 2. If I take 4 from that, I take 4 from that, being really slow, minus 2, and I've got z equals 2. Now that I know that x is 1 and z equals 2, I can go back to here and get the y. I can go back anywhere, by the way, and do the calculation. It doesn't matter where you go. So now I've got a 2x plus a y equals 5. So I've got 2 x's up here, x is 1, so I've got 2 times 1 plus y equals 5. I subtract 2 there, I subtract 2 there, and I've got y equals 3. So my answer is x equals the 1, y equals a 3, and the z equals a 2. Oh, we're there with no silly mistakes. If you're enjoying it, please tell your friends, spread the word, and encourage me to make a lot more. I've got a lot in my head, just getting around to doing them all, finding time and opportunity. Hope that helps.